For Unit 6, Lesson 1, we will be discussing chemical kinetics. Kinetics is an area of chemistry concerned with studying the speed or rate at which a reaction occurs. Throughout this unit, we will discuss how we speed up or slow down a chemical reaction. In order to understand how we manipulate the speed of a reaction, we first must discuss how a reaction takes place. We use the collision theory to model what is happening in a chemical reaction. First, reactants must collide. Second, they must collide with the right amount of energy. And lastly, they must collide with the correct orientation. There are four main factors that we can use to manipulate the speed of a reaction. First, the state of the reactants. Second, changing the concentration. Thirdly, changing the temperature. And finally, adding a catalyst. When discussing the nature of reactants, the main variable that affects it is surface area. Having smaller particles with a larger surface area will react faster because there's more exposure of the particles of our reactants to collisions. Increasing concentration will also increase the rate of our reaction. And again, this happens because there is a greater chance of collisions. Having more particles present in our reaction will result in a greater number of collisions. The third factor, temperature, has the same relationship. Increasing the temperature increases the speed of the reactants. This causes the reaction rate to increase because there is a greater collision frequency between the reactants, and the reactants have more energy, meaning when they collide, they will have a greater chance of turning into products. Adding a catalyst to a reaction also increases the reaction rate. It lowers the activation energy necessary to convert the reactants into products. However, the catalyst does not get consumed in the reaction, and it does not make the amount of product that you produce change. It just makes you get the product faster. We can also calculate the actual rate of a reaction. It is expressed in units of concentration over time, or molarity per second. We take our change in our quantity divided by the change in time. Remember, delta means change in, always final minus initial. When you look at the second equation there, which is the same as the top, brackets mean concentration. So concentration of our substance at time 2 minus concentration of our substance at time 1. Whenever we calculate the rate of a reactant, it should be negative because we are losing reactants. And our product should always have a positive rate. Let's try an example. If our concentration of our substance is 0 at time 0 and 0.01 2 seconds later, what is our rate? And that's the end of this first lesson. Make sure you hit the like button and follow me at Miss Gates Science.